Hey everybody, today I will be doing my first math tutorial in 2019, and it's going to be another YouTube channel. I'm not going to be using the old one anymore. So in this brand new channel, I probably add some more stuff beside mathematics, but for the meantime it's going to be mathematics, right? So okay, so let's do this. Okay, so find the integral of this expression. Okay, and we will be using the U-substitution method. Okay, so we analyze the problem. We see that we don't have a limit of integration, right? So it's indefinite integral. We know that we have a trigonometric functions. We have a sine squared and we have a cosine squared, right? Sine squared 3x, sine squared 3x, cosine 3x dx, right? So that is the function again, sine squared 3x, cosine 3x dx. Okay, so let's analyze the problem. We see cosine 3x and we see sine squared 3x. Okay, this is more complicated. So therefore, we let u equal to one of the signs from this, because in order to get this, two signs will be multiplied, right? So sine times sine is sine squared, right? So we will let u to represent sine 3x. Okay? So u is equal to sine 3x. Then we want to see, we want to use we want to use we want to use the U-substitution, so we have to take the derivative in order to get this dx, right? So we want to say that du is equal to dx, right? So we want to get this. Our goal is from the u, from the representation of u that is equal to sine 3x, we want to get this cosine 3x. Okay? Again, from the representation of u that is equal to sine 3x, we want to get cosine 3x. Okay? So we take the derivative of this and we get with respect to u, right? So du is equal to derivative of sine is cosine. Then we keep the 3x. Using the chain rule, we take the derivative of the 3x. The 3x, which is simply 3. Okay? Then we can rewrite this du is equal to 3 cosine 3x. Divide by 3, divide by 3 on both sides, and I get cosine 3x is equal to 1/3. So cosine 3x is equal to 1/3 u. Okay? So now we got this, right? We got the cosine 3x is equal to 1/3 u, which we already got this function right here, right? This is the same as that, right? And 1/3 du is actually this dx here. Okay? Now, to, let's represent this expression only in terms of u, right? So now I can represent this expression in terms of u, okay? So we let u is equal to sine squared, right? I'm sorry. We let u u equals sine 3x, okay? So, but then remember that we have a square here, okay? So we can say that the integral of u squared du over 3, right? 1/3 du, right? This 1/3 du can come out, and I can say that 1/3 du, the integral of u du. Take the integral of this, okay? I add 1 to the exponent divided by the new exponent, and this is going to be 1/3 u cubed over 3 plus c. Okay? So now I just multiply this times this, it's 9 u cubed plus c. Okay? Then I substitute this back. Well, u was equal to sine 3x, right? So therefore 1/9 sine cube 3x plus c. Okay, so that is the answer. That is the integral, right? Now let's take the derivative of this and see if we get this part here. Okay? And then erase this. Okay, so I'm going to take the derivative of this integral, and I'm sorry, let me rephrase it. I want to take the derivative of this function, because technically this is original function, right? And see if I get this expression, okay? So dx 1/9, okay, 1/9 sine cubed 3x, okay. I don't bother writing the plus c because it doesn't really matter anyway, because it's just a constant, okay. We don't even know what c is, can be anything. Okay, so let's do this, okay? Take the derivative. Okay, when I take the derivative of this, it's going to be equal to, this comes to the front, right? This comes to the front, and I get 3 1/9. Then I subtract 1, right? Subtract 1. This comes to the front, and subtract 1 from the exponent. Subtract 1 from the exponent, which is equal to sine squared, right? 3x. Then I take the derivative of sine, right? The derivative of sine is cosine, right? And I keep the 3x using the chain rule, right? Remember, using the chain rule here, taking the derivative. Then I take the derivative of the inside, right? Of this 3x, which is equal to 3. Okay. Now let's do it here. So now let's do this. So this 3 here cancel with 3 here. Okay. This 3 here cancel by 1, right? And then the 9 cancels, right? This 3 goes into 9 3 times. Let me just to be clear, okay? Then this 3 here cancel with this 3 here, okay? So if I rewrite this expression here, I get sine squared 3x cosine 3x dx. Okay, so we got the same thing. We got the original derivative that we started with. Okay, so that's how you prove that this integral is correct. Thank you for watching. I hope this helps. Anybody who is taking calculus 2 and hopefully that this will be helpful. Thank you for watching.